Hey, welcome to another procedural texturing tutorial. Today we're going to be making a kind of beat up oil barrel. It's going to be on muddy ground. There's a few techniques that are really useful in this because obviously things in real life get dirty, they get beat up, they get scratched, and they get worn in particular ways. And we can do all of these things procedurally with a few fairly simple tricks. I'm using Blender 2.90.1 and I'm going to be using the Node Wrangler add-on. Make sure you've got that enabled. And also there is a link in the description to an add-on called TexTools. This is a super useful add-on. It's going to let you bake some extra maps like curvature maps. Definitely recommend downloading that one. So to begin with, we're going to need an actual barrel. First things first, we need mud. We are working in cycles. We will be using shader displacement. Let's just grab a texture coordinate node, set to object, and we're going to grab texture, noise texture. So here's our first issue, right? So different objects, different scales, which you may have and you may need in a scene. For example, if something is instanced, you are not going to be able to apply the scale. In this scene, it doesn't matter. We can just apply the scale and it looks fairly good. But what happens if I start putting stuff like this on here? So straight off the bat, you can see that as we come up to the edge of something, we get this abrupt change. Obviously, it's not realistic. So the way that we get around this is we use the world position. This is completely independent of the object information. So we can use the geometry node position. Now you can see that our noise pattern continues undisturbed by the changes in surface. Now we're going to do something that is a little bit odd, but I think it gives some really nice results. So this color information, this has got 3 channels of noise. If I take a separate RGB, we're going to be using a mathematical operation called logarithm. So if we jump into cycles here, and I'm just going to turn off the scene world for a custom HDRI here, we're going to view our principled node, and in the material options, I'm going to turn on displacement and bump. In the settings for the plane, just for the floor plane here, so I'm just going to do a subdivision, set it to simple, adaptive, and I'm also going to set my viewport dicing size down to 1 pixel, just because this is a very simple scene, so I think I can get away with it. I'm going to add a vector displacement node, and we're just going to plug this into the height socket, and that's going to go through there. Very, very high frequency noise at a very high scale. Reduce that way down. I'm going to increase my scale here to 7, and you can see straight away we've got some pretty cool stuff going on. Going to use a map range, so converter map range. So this is clamping at the moment because we are basically going above 1. For a start, I can just bring down the base layer here. So I can see this is starting to clip in some places. So I'm just going to go back to 0.3, just to make sure I'm not clamping off any of the bases. And then for the top, I want to increase this to around 3. Still seeing a little bit of clamping there. 3.5 should be fine. Now I can reduce this again. Now, just for us to have a little bit more control, this is going to be a node group that you can keep and use in the future. So I'm going to add a color, mix RGB, set this to color burn, and the second color naturally down to black. Now, depending on your taste, you may not need to go all the way to black. I'm going to set this to like 0.15 as a default. And then we can do a few things with this. Mid-level of this is going to be 0. This basically means that the areas that are puddle, they are the ground level. And then we want to have a little bit of color coming into our surface. Obviously mud is not just grey. So I'm going to duplicate my color burn, set this to mix, have it mix between a brown color like this. Let me just drop this up into the principled node here. So that could even go a little bit darker. And the color in slot 1 is going to be a slightly lighter and slightly yellower version. So this is kind of stirred up mud in water. And what I'm going to do is I'm going to add a little bit of fall off, but essentially it's taking this color burn output. We're going to take a converter color ramp. We're going to pull this way back, just like that. And this is going to come into our socket here. I think I want to add a little bit more color variation. So I'm going to add a noise texture. I mean, if we have a look at this one, pretty good, but it's also too high scale. To even take the color from the other one and plug it in there. I'm just taking this color output. If we duplicate our mix here, right, and we're going to plug this into that color, I'm just going to drop our mud color up here, set this to multiply. So now, see that as we increase this, start to get something that looks kind of like oil on water. We are just going to control the roughness. Obviously, water is shiny. We're going to add a color dodge after our color burn. And then this is going to go into our roughness value here. So our water always wants to stay completely wet looking, but our ground wants to be drier. So select everything, Control G to put it into a group, and let's start putting some scale values in here. Scale into scale, scale into scale, and we also want to control the height of the displacement with our scale value as well. So I'm going to add a converter math node. I'm going to set this to divide. I'm going to plug our scale into the bottom of it. So we are doing currently 0.5 divided by our scale. There we go. Around 0.1 looks actually fairly convincing for mud. And we want to have that controllable from the outside. So we have our general, like our overall texture scale. Then we also have our height multiplier. So now we have a controller on the outside of the node group here, which I'm just going to call mud. So now we can control the height from outside, but this also remains consistent for changing the scale of the overall mud texture. We have our wet dry amount, which is up here. I'm just going to change this to an even number, 0.9, before we connect it. So any value which is in a socket already, that gets assigned to be your default value in your input. Just going to set mine to 0.9 just to set it up already. And then I'm going to call this one wet dry. And then after that, I also want to have my puddles. This is set to 0.15. That is to puddles. Last thing that I think I want to add is going to be this multiplier up here. And this is the amount of oil on the mud. So I'm just going to call that one oil. So now we have this controller here. I'm going to rename this material ground. And then I'm going to create a new material for our keg. A new one, which is going to be called keg. I'm not actually sure. Are these actually called kegs? Maybe they're not. The oil can anyway. So in this material, we can add our group. This is why we use groups, because groups allow us to have consistent materials across multiple different materials. So things like this mud, which I can have on here, I can remove the puddles from this version of it. I can plug this displacement across as well. And you'll be able to see on here that we have a little bit of displacement coming on it. I'm actually just going to increase the displacement amount, particularly on here. So one thing that would be really useful for us to have is the actual, the noise as a value rather than as a displacement, right? So I'm just going to plug this through, rename this to noise. Now on the outside of our mud node, we have the noise of the mud texture. And if we go across to our ground texture, you can see that this one has also gained this socket. So to all intents and purposes, ground texture is now finished. So we can just focus on the keg. I'm just going to connect this displacement across. We're keeping the height multiplier fairly high here. I'm fairly sure that I do not want to have, I don't want to have displacement on here because this is really messing this up. I'm going to make sure that displacement and bump is turned off to just be bump only on the actual keg. The next group that I want to make, rust. Rust is a pretty easy one. We're going to make it into a group. So again, something you can use in the future. Add a geometry node. And again, we're using the position. And again, we're going to be using noise. Position, like I said before, is going to let you have noise moving across multiple objects. So let's throw on a noise texture here. I'm going to up the scale to say 30. Maybe that's a little bit too high. Maybe go something like 20 for now. Detail at 5. Separate RGB. Add a converter math. Set this to logarithm. This is where things change a little bit. We're going to put a divide afterwards. So what the divide does is the more we divide by, the more rust we're going to get. All right, so as soon as we go to 0, it's like tending towards infinity. This is a nice little controller for us to have on the outside. So after this, I'm just going to set this to 5 or something. I'm going to add a converter color ramp. I'm just going to throw in a few colors here. Just pick yourselves some somewhat rusty colors, kind of mid-oranges, and then I'm just going to bring in my whites here. So you can see as I reduce this, we're essentially going from having no rust, and then it starts to kind of creep in until it's covering the whole thing. This is our color. Just going to throw this onto a principal BSDF. I'm also going to throw just reset this with backspace. I'm going to plug the color in here, and this is going to go into our roughness. Just going to make sure that we've got like a really even color. The surface can be a little bit darker because it's more likely to be. And I'm also going to throw this through a bump node. Bump into here. I'm using the color ramp output as the height here because we're going to have a clamped off region. I might actually just come a little bit lower on here, just so we're not actually clamping in the middle. So it's still giving us a nice little bit of wear there. And I'm just reduce that distance on the bump node. Time to make this into a group. Select it all, Control G to make it into a group. And then we're going to add a scale here. So this is our overall scale. Just tab out, make sure this is set to rust material. So I want to have my rust amount on this divide here. Rename this one, call it amount. And then on the outputs, we're going to have the color output as well as the BSDF. And then we're also going to have just our logarithm output here. So you can just plug into a socket like this. This is our noise output. And there we go. That's our rusty material, scene 2. We can obviously change the rust size here. We're only using a single asset. Obviously, if you had multiples, then you might want to use the same rust group in multiple materials. And that is going to allow you to have rust moving from one object to another. I'm just going to set this to something around here, and I might just increase the amount of rust that we've got on here, something like that. There's a few things that we want to add. I'm just going to make sure that we're in CUDA. So I generally work in Optix because it's a lot faster for me, but for this process we're going to need CUDA. If you are in 2.9 or later, then you don't need to worry about viewport denoising, but if you're in version before 2.9, then you're going to need to make sure that you have Optix denoising turned off as well, or it will not render. To do an edge detection algorithm, as it were, we just need to add a bevel node. You can see if we have the radius set to 0, we just get the normal geometry, normal. There we go. So you can see with radius set to 0, this is just that. If I set this to 0.5, then you can see that we are beveling the normals, right? If I drop this onto normal input with or without, you can see it's faking it, but it's trying to round out the shading. We're not actually using it as a bevel per se, we are using it to find out where the bevels are, and this is how we do the edge detection. So normal into normal, add a converter vector math node here. So normal into the vector math, change it to cross product against the normal geometry node here. So now if you look at this, we've got some interesting things starting to happen. I'm going to add another converter vector math, and we're going to set this one to length. If I increase the samples up to 16, that's going to give us a better look, and reduce this to 0.03 or something similar. You can see that every time we have a change in direction, we're getting a bit of a bevel. Let's have a look at our alternative options here as well, just so that we know what's available. So also on the geometry node, we have Pointiness, and Pointiness is a good one. It's very useful for doing things like rocks. In terms of organic stuff, it's great, but it's quite hard to control. So if I was to put this one through a color ramp, then you can see that we have high points and we have low points. If I was to go one step further and just try and make it the same as our edge detect by putting a ping pong in here, right? So now it's going to go, instead of the sharp external corners being bright and internal corners being dark, now they'll both be dark. So what's the benefit here? We have a hard fall off. This is being calculated from the actual angle of the geometry, which is quite useful because it means that we can use something like a greater than, whereas the bevel node, you can see even though we're using a greater than, because the bevel is samples, this is giving us a soft fall off. So this is your kind of standard edge detect algorithm using geometry normal into a bevel, turn that all the way up, cross product, length, and that gives you the beveled edges as highlight. Another thing that is worth being aware of are dirty vertex colors. So on a mesh like this, we have not a huge amount of geometry, but it should be good enough. Even though we're in Optix, we can still do this. So I'm just going to go into the screen triangle, which is the Object Data Properties tab, Vertex Colors, add a new layer called Dirty. Now if I go and change this viewport mode into Vertex Paint, I'm not going to actually paint anything. I'm just going to click Paint, Dirty Vertex Colors. Now I can go back into Object Mode, and in here I can go Input, Vertex Colors, Dirty. So any internal angle gets a darker value. There is an add-on called TexTools, and it is really, really useful. It has a lot of functionality, a lot of options. I'll put the link to the GitHub down in the description below. Do consider donating to the guy if you do download it. There's a link to do that there. Just a huge number of tools, really useful add-on. So once this is enabled, in your UV editor, you have this additional tab. So I'm just going to bake out a couple of 1024 by 1024 maps here. And I'm actually just going to mark a couple of seams here. So this is now newly unwrapped. I'm going to go to baking here, and let's have a look at some of our options. So we have options for AO, bevel, cavity, curvature, dust. You do need to be in CUDA to bake out bevel and AO. It uses the same part of code in the backend to do that. However, once they're baked out, obviously you can then use them with Optix. So let's generate ambient occlusion map, and I'm just going to hit this bake. Right, so that probably took me about 40 seconds to bake that, but it does show that you've got all of this information now as a texture map. So if I was to add an image texture here, add the cylinder AO and view that, then you can see that this is the baked AO map. Let's bake another one. Let's do the bevel mask. I'm going to reduce the radius to 0.03 and increase the bevel samples to 16, and then I'm going to hit bake again. There we go. I timed it that time and it took 11 seconds. You can see this map has all of our edges. So CTRL+SHIFT+D on this image node, change this to the bevel mask. As you can see, we have all of our bevel details. I'm actually going to use these. I know this isn't super procedural, but I think this is a really valuable add-on. I'm just going to pull this down here, and I'm going to save these real quick. So save all images. This has basically packed it into our file. So if I now save the file, you'll be able to see that in our Blender file view, images up here, we have cylinder AO, cylinder bevel mask. These are by default taking the UV map, but just so I have that control if I need it, Alt right click gives me this quick connection, so I can just do that. Bevel node and ambient occlusion, both super useful, but also both unavailable with Optix. One more thing I wanted, dust is really easy to do. So we're just going to take a geometry normal and we're going to just take the separate XYZ and we're going to take the Z and convert a color ramp. This is where things fall on the top surface. The final thing that I want to try and do here, scratches. So this method we're doing scratches is thanks to Charon from Just 3D Things. There's a link in the description down below to his channel. He's really great, he does a lot of math stuff, really knows his stuff, so go and check him out. He just released a video on November resources. So if you're interested in getting into November, definitely check out that video. I'm going to be doing his method for scratches, which is taking a noise texture. I'm going to be taking just object coordinates in this case because we don't need these to go anywhere else. Although if you were working on something which had multiple objects next to each other, you would want to use the geometry position. For our noise texture, we're going to take the color output. Now, this can be a little bit bigger, something like this. And we can turn down the detail. I'm going to go converter, separate HSV. Personally, I really like the H value. I think it looks like a really nice watercolor kind of thing going on here, wet edges. However, we're going to be using the saturation value. So we're just going to use the saturation value here and I'm going to put it through a color ramp. I'm just going to crush down the whites, lift the blacks very slightly. We can increase the distortion on here. So what's good about doing it this way instead of something like a Voronoi crackle is Voronoi crackle gives you straight lines and then you have to add noise to it afterwards. And then you also have to add noise to mask it and make it kind of break up that pattern. This one is really great because it gives you just scratches and straight away. It's really good looking. I'm going to make this into a dark blue oil keg kind of thing. It was somewhere around here. So I want to add a little bit of bump and variation into the surface of the paint. So take a vector bump node, plug that into your normal, and then we have a few options here. So I've got obviously this one out of the scratches that we just did, but we also have this one out of our rust and this one out of our height for the mud. I think I want to use the rust one because we're going to be mixing some of the rust with it and it will just look a bit more natural where the paint blows. What I can do is I can just take this noise into the height. We have a look at this. Obviously it's much too strong. Something around there is absolutely fine. We have a general texture that is a little bit too neat. So we're going to add our scratches. Scratches obviously go down to the metal, two different materials being shown. So we're going to need some mix RGBs on here. I'm going to be using this as a mix factor. So the white is our paint color. So that's going to be the second color here. Preview this again. And I'm just going to want to have white to the input. I'm going to reduce the black point and I'm going to pull in our whites here just so it's really like a tight thing. My scratches are black, so I'm just going to use a color mix RGB and I'm going to mix in between these two. I'm doing this just so I have a little bit more control over how much scratch I get. In fact, if I set this to multiply, then my scratches will remain black, but we'll just be adding the noise into the white areas. Now we want to add some rust into this surface. So obviously we're taking the noise and we're going to mix the rust with our principled node. So if I just go Control Shift right click and drag, that's going to anchor these two together. And what I'm going to do is I'm just going to take color ramp on this output and I'm just going to increase this until this basically becomes our mask. If I view this, then we're going to need to Alt S to switch those two around and I'm going to bring these down somewhere around there. So obviously this is way too much rust at the moment. So I'm just going to reduce this down somewhere like that. I also want to actually make it a bit darker. It's looking awful bright. Make sure it's a little bit more saturated. Well, just because it's so stark against this blue color that we've got, might even go a little bit higher on the scale just so it's more like rust patches. And you just need to choose basically based on your sensibilities about what this should look like. Let's have some additional edge wear. So we could have wear affecting loads of different things. We could have it affect the color. We could have it affect the amount of rust. And these are all things that we need to be aware of that we have as available options. In this material, I'm not going to use the AO. So let's take our bevel mask that we baked out of TexTools, and I'm just going to put it through a converter color ramp. Give me these controls, and this is going to let me see what's going on here. Let's throw a map range onto here. So we've got 0 to 1, right? Color ramp clamps, and also images are clamped anyway. So 0 to 1. This is going to go into our rust amount. By default, we had it set to 2, so 2.2. give or take, but I want actually more rust to appear on these edges. And this is something that we can do just simply by using our mask here, our bevel mask. And you could absolutely, if you're using CUDA, then you could just be using the bevel setup that we used earlier. Now I don't want these to be completely like 100% rust, but I'm kind of erring on that side. That's added to our rust, which is, I think, really nice. It's quite convincing. And on that note, I'm going to actually turn down the amount of rust that we've got elsewhere. So just tweaking this one to make sure that we don't have any of this halo. I'm just going to reduce this one to like 1.7. Looks fine. And I'm also going to increase the scale of these scratches up to like 4. What do we have remaining? We have mud and we have dust. So mud goes on the outside because it's the final layer of the material. If if we've beaten something up and we dropped in a field, the rusty is going to come from the metal. It's going to come from kind of the inside essentially. And then the mud is going to be caked on the outside. You also need to think about what the mud is. Now we'll see this thing has been dropped and puddles in the field. So it's going to be raining. If you look at the bottom of any building, you'll see this. You get rain marks on the bottom of the building where it's splashed off the ground and it's picked up dirt. I'm just going to Control Shift right click and drag on here. We're going to do something with this dust mask as well, which is our top mask. Not sure quite what. Maybe we'll do UV damage to the paint just to make it look a little bit faded in the sun. So for us to decide where we want our mud here, I'm going to match the scale. So let's set it to 3. I'm going to add a texture noise texture here. I'm going to make it a little bit bigger, at about 2. And we'll play with these once we've got a better idea of what's going on. So we could have used the ambient occlusion map here. Let's just bring it back for a second. In this case I won't, because I want to show you a different method. If I was to plug this into our map here and then convert a color ramp on here, throw this stuff about, you can see that we've got we have mud at the bottom, which is great, and we've got it inside these corners, which is maybe realistic. I'm not quite sure about that though. What I'm actually going to use is I'm going to use the Z position. So just because we're only working in like a kind of vertical Z above what is essentially a plane with this floor level, I can just take a geometry position, which is our world position actually, and I can take a converter, separate XYZ, and I can take the Z. You see this is already actually zeroed out. You may have to add or subtract depending on your setup. And just taking our noise texture up here as well, I'm going to plug this in so that we have an even noise, and I'm going to take a color, mix RGB, and I'm just going to burn this together. Right, so 0 factor with geometry position in the first socket, we get like a flat gradient to begin with. Now, as we increase this, you can see that we are essentially bringing it up where the noise is darker. So I can also just add a little bit of distortion on here. I might just add this to like 1. I'm also going to add some detail here. I'm going to go up to about 4. I'm not going to add any roughness. We're going to stay at 0.5 there. This black goes way too high. Just so that we have a little bit of control, bit of manual control. I'm going to add an add in here. So the more we add, the lower that goes. And then I'm also going to add a dodge. This is just going to give us control over the white point. So this is our mask. Nice and simple for us to do. Plug this into our mix shader. You can see we now have mud at the bottom. We can now connect our displacement to the displacement. And now you can see it's messed everything up here. Mix RGB on here, because this vector, blue socket, so it's an XYZ vector, we can just mix this with black, basically, with the same mask. We have displacement on the bottom, right? And I can increase this. It is just bump, but it just makes it look a little bit more like it's seated in the ground here. Something cool that we could do actually is we could add the oil effect localized around the barrel, and that would be something that we do to the ground, right? So it looks like it's losing, sort of seeping out some oil here. I'm just going to take this dust down here. I'm going to add another mix with our base color in it, and this, we're just going to use this as a mix factor in here. We want to have a little bit of discoloring on that surface, and we can do something like that. If you want to remove or lower the effect of it, we can always just reduce the value and that white point, just so it looks a little bit faded. Somewhere around there feels about right to me. Just going to add that last little bit of oil to the floor. I can just take an input texture coordinate node here, take the object coordinates, color pick our cylinder. We can take a converter vector math, take this as the length, and then this is essentially going to give us a spherical gradient coming away from the keg here. So if I just take a math node and subtract, you can see that it's starting to come out in a circle formation. Do we have any alternative options though here? Can we use something like ambient occlusion so it actually fits the mesh? Well, yes, but we don't have it with Optix. We're just going to go and use TexTools real quick. This is not sponsored. I just want to make sure you're aware. So we have a thing here. I'm just going to go to ambient occlusion like this. Make sure it's 1024. Make sure we have our plane object selected here. And I'm just going to hit bake. So this is just finished baking. We have got our keg cut out in the middle, and you can see a little bit of gradient around it. So something that you have as a bonus when you're using CUDA is that your ambient occlusion node will respond to your shader displacement in a way that your ambient occlusion baked images do not. So in this case, it's going to be fine for what I want, but just something to be aware of. If you're baking and you're using shader displacement, you're not going to get the shader displacement information from using the TexTools method. Let me just jump back into Optix here. So what we're going to do is we're going to grab a texture, image texture with our plane AO. You can see if we add a converter color ramp to this, if I pull this out, then we're starting to get like a good area that has some shadowing on it. Because I'm not actually needing to look at this, we can use a map range instead and plug that BSDF back in, and we're going to plug our map range into oil. By default this was 0.2, and where it goes lower towards the can, I want to increase this. Fairly subtle, but it does the trick. Hopefully this was a useful process, more or less all procedural. If you're using CUDA, you can do 100% procedural, but doing it this way gives you a nice balance of speed. So there we have it. This is a fairly reasonable process for weathering and wear on something like an oil barrel. So coming out of this, you've got the muddy node group. There'll be image of the nodes down below for that, as well as the rust node group. There'll be nodes for that. So you can double check against those. Yeah, weathering and wear is just one of those things that is going to really help with making models look a little bit more compelling, a little bit more realistic, more grounded in the world that you're trying to articulate. So there we go. Thanks for watching. Hope you have learned something. Hope you've enjoyed it, and I'll catch you next time.